Hello everyone, welcome back. Thank you so much for coming back and also continue this conversation with me. So in the previous video, we briefly introduced the idea of coordinate geometry. And we also mentioned the tools we are going to use is actually these two formulas today. And so in this video, we are going to focus on the slope formula. So the slope formula, when you see it, you probably recall something you learned in Algebra 1, or the words like rise over run is in your mind, which is all correct. So slope formula is one, for example, when we give coordinates of the 2 points, then we can easily to find how slanted a line look like. Sometimes it's like that, sometimes it's very deep like that, or sometimes it's very mild like that. So slope is one to describe the line, the tendency of the line, how it goes. So the formula is like this. We can just easily plug in the value to finish the calculation. But what do we use the slope formula for? We use a slope formula to prove, that's a very important part, two lines are parallel or two lines are perpendicular. And today we are going to focus on two lines are parallel. So what does that mean? When two lines are parallel, if two lines are parallel, then they have a same slope. So easy word is when two lines are parallel, the slopes are same. Vice versa. So that means if I can show the two lines having the same slope, that means they are parallel. So if I can show they have the same slope, then lines are parallel. For perpendicular is different. For perpendicular is two slopes are negative reciprocal. This conversation we can have another reciprocal. Oh, sorry. I'm going to rewrite this word. It's like upside down, so flip the reciprocal. So this is not the focus today. We are going to focus on the parallel. Reciprocal, using reciprocal slope to prove the perpendicular is going to be the different lesson. But today, on the very first part, we are going to focus on if you need to prove the two lines are parallel, then the slope formula is a good choice, because when two lines have a same slope, then these two lines are parallel. So now we are going to use example here to show you how to do the calculation for slope and how do we use a slope to prove two lines are parallel. Let's check this example. So in this example, we see two lines here, or you can see two segments, two line segments. It's actually have ending points here. So two line segments here. And the question asking us, are these two line segments parallel? So some student might say, it looks like they are never intersecting, so of course they're parallel. This kind of observation is not going to be a solid proof. We cannot say they do not intersect, then they are parallel. Because the idea of not intersecting is not really proven. You have to use some solid evidence to prove if they're parallel or not. Then the tool we're going to use is actually slope formula. Because as we mentioned, when two lines are parallel, they have a slope. Same thing, when they have a same slope, they are parallel. So what I'm going to do is we are going to do the calculation for finding the slope of each segment, and then we are going to compare if they're the same. Finally, we are going to come to the conclusion to say, hey, they're actually parallel. Or if it's not, then we can still come to the conclusion they're not. So this is how we use coordinate geometry to prove it. So let's find slope of AB first. Again, slope formula, as we mentioned, is you can see is y2 or y1, doesn't matter, but make sure the order of the denominator and numerator must be the same. So I'm going to read the coordinates of A, which is 2, 6. Let's label on the graph. It's easy to see. For B is -5 and 2, right? And for C is 5, 2. Do not forget you read X first and Y. For D is -2, -2. Okay, now let's do the calculation. Sometimes students prefer to write like this, AB equals. This is wrong because you are looking for the slope. It's not like AB equals something. So please make sure, be patient with this process and write more words to indicate what kind of calculation you are doing. So we are going to plug into the value here, y2 minus y1. So 6, this is y. So make sure you label xy in case you forget which one is the order, minus 2. And then I use a at the first point, so I'm going to stick to that. So 2 minus, do not forget, it's always minus, but this is -5, so put it here. So 6 minus 2 is 4. 2 minus -5 is going to be 2 plus 5, which is 7. So that's a slope of AB. And then I'm going to do exactly same thing for CD. Again, plug in the value. Do not forget the order you use. Do not forget if this is going to be a negative number or not. So double check 2, -2, so 2 minus -2, 5 minus -2. The order does matter. And please make sure x is on the bottom, y is on the top. And 2 minus -2 becomes 2 plus 2, 4. 5 minus -2 is 7. So you see, we do have same slope. You don't need to convert to decimal. As long as we can see there are exactly same value here, they are the same slopes. So now you may say, are we finished? Not quite, because when we finish the calculation, you'll need to explain what is your calculation? What does your calculation mean? So we are going to write down the final conclusion here, AB, and so you know what? Let's just use a symbol, AB parallel DC, because they have the same slope. Because in coordinate geometry, same slope, meaning they're parallel. So that sentence gave you is served as conclusion. Just like when you write an essay, you always, list your evidence. First, give the claim and then list your evidence. Finally, you are going to use a conclusion to re-summarize your idea, your opinion. So very similar to the way with that. We show the calculation and finally we are going to use one sentence to explain what the calculation means in this situation. Okay, so this is how do we use slope formula to complete the proof of proving two lines are parallel. I hope this is helpful. Do not forget we have another formula. You can definitely take your time to study these videos, but do not forget to check another video when you have time and to understand what is the distance formula for. Okay, see you soon everyone. Thank you so much for watching this video and study this topic with me.